I am from Gradle Summit, and thank you for joining me for my talk. I will tell you about our journey to CERN, how we adopted Gradle for building our control system. And Endre, Fejes, and certainly working in the development of the team.
Are we going to be on comms for this one?
First, let me give you an overview of what I'm going to talk about here. So I'm going to give a very quick intro into what our environment looks like and what does that mean to in terms of the restrictions of development tools. And then I will quickly run through how our migration went from an old build system to Gradle. And most importantly, I'd like to point out a couple of things that we benefited a lot from how Gradle helps adopting. But also, I would like to raise attention to a couple of things that we found a little bit restricting or problematic with Gradle. But as it turns out, even in this keynote, as before, a couple of these were addressed, so happy to hear them. So, to show you what's going on with the build control group at CERN, let me show you a very quick video. So, I'm not sure if you can hear much of it. This is where we are. And this is our nice and big accelerator complex that we're accelerating photons and other particles to get them into different experiments where they can collide and observe them. So, that's just a very brief intro of what's going on CERN. But to give you an idea what users are dealing with as development tools team. So we have around 100 professional Java developers. Of course, they are working on the frameworks, core libraries, and the server applications that help control and make the Accelerator Control System work. But also, which poses a bit more of a restriction or difficulty, we have around 80 domain experts who are mainly physicists and operators. And they have the domain knowledge, which is unquestionably needed for our organization to work. They know what is needed because they control the equipment, so they know what GUIs they want to look at, how they should look like. And more importantly, they want to contribute. They want to be able to change these applications easily without having to go through discussions with developers necessary. On the other hand, because they have a physics background, usually they have limited software experience. So for them, it doesn't really matter what the developers' tools do, as long as they work. For them, the most important thing is that once they wrote the code, that they know that works and they understand what that should do. From that on, everything just has to work. And to give you an idea also about what scale of systems are we talking about here, we have a little bit more than 10 million lines of Java code that are scattered across over thousands of projects. And they are organized in more than 20 levels deep dependency hierarchy. When I say organized, well, that's probably an exaggeration. It looks something like this. So the dependencies are a bit of a problem always. But we have other limitations as well. We are not Facebook or Google or any big .com companies, so we have a slightly different approach and different aspect on development than most of these companies do. We don't have a degraded mode, so for us to be able to say that our systems are working, all the systems have to be operational. We cannot let one server go down because then we cannot do physics. We have limited testing capabilities. We don't have a spare 28-kilometer circumference particle accelerator in our backyard to do A/B testing, especially not a bunch of them to do canary testing. So this limits what we can do in terms of automated test solutions. But most importantly, probably, and because of that, we have to focus on how we can provide stability and reliability through our developer tools, even if that costs us the ability to move to the most cutting-edge technologies or cutting-edge development practices. It's not to say that we ignore them. Here we are at Gradle, and we want to use it. But still, our main purpose is, and main goal is, to enable the physicists to do physics. And who we are the development tools team. And again, the purpose is to provide tooling for the Java community, and especially keep in mind the less professional software developers. We have to make it simple, accessible, and convenient for our users. We also have a mandate to make everything traceable. So we have to make sure that whatever is produced, and especially if something gets into production, we can understand if that something goes wrong, then where it came from and what happened. All right, so let me walk you through how our migration went. We started from an old build system, and as you can guess from the logo that we saw before as well, it was an unbuilt build system, more than 15 years old, with all that legacy. And one of the problems with it was that it did not scale. When it was designed back then, it was designed for a couple of dozens of projects and a similar number of developers. The dependency resolution in its core was done by Apache JJAR, which you might know that was discontinued. We tried to keep it alive for a while, but it just didn't make sense. And as many of the similarly old systems, it got patched over and over again without having time to redesign it and restructure it. And lastly, it's not our primary focus necessarily, but it lacks support. We missed the active plugins and the nice features that, for example, Gradle offers for us. So apart from the obvious requirements of fixing the above issues, we had another big topic. We had to make sure that if we migrate to a new build system, Gradle, then the transition has to be smooth. What I mean by that is that we didn't want to spend a lot of time on refactoring and restructuring our projects. We didn't have to spend a lot of time on training. Again, we have developers whose primary job is not necessarily development. So for them, having to understand how Gradle works internally is just something that we didn't want to do. And we wanted to reduce the support overhead as well. So by not spending a lot of time on training, we still didn't want to get a lot of problems. Overall, the bottom line is that we wanted to change the build system, but we didn't want to change our users or the projects. And how it went down, let me just give you a quick timeline. So the project that we are talking about, or the project system, is the Java control system, and we started development in '89. And a couple of years later, the old build system, the build tool, was introduced. And it wasn't until 2011 when it first occurred that it should be replaced. At that time, we tried it on Maven. Well, that didn't work out. And shortly after, an attempt was made to investigate Gradle and see how that would work. And luckily enough, it worked out well. And in 2015, we started migrating a few projects to drive out the kinks and see what else needs to be done. And by this year, we were able to migrate first the core projects, libraries, and frameworks. Obviously, we started with the professional software developers. And already, we migrated almost all of our projects. So a couple of things that I like to point out, what we feel as was the most important things that helped us making the transition, what enabled us to adopt Gradle. To give a quick example, it's not something that is very fundamental, but it shows how nice Gradle can be in terms of flexibility is the flexible versioning. We have a requirement where we want to create snapshot-like releases, so something that is similar to Maven snapshots, but with a fixed timestamp as its version. And it was very easy to do. We just had to define a suffix, append it to the version, and there you go. Instead of snapshots, you get the timestamp as a suffix for the version. And this worked perfectly for us. And of course, as Gradle can be dynamic, we were able to make it on demand. So when it was not needed, we were able to turn it off and on with a simple property. So again, this is not obviously the most advanced example, but it shows how simple it is to do anything with Gradle. Moving on to another topic that we found a bit more powerful, and it was a really enabler for making the transition, is the ability to generate tasks on the fly. Let me show an example what I mean by that. Actually, this was something that was mentioned in the keynote as well, how you might want to generate different variants, and for different variants, different jars maybe for your project. So let's say if you have an application, you have a build.gradle, and then you have a configuration for two-tier application and a configuration when the application is used in three-tier mode, and then you have some Java. What you want to achieve is to generate some jars in the lib directory, one for the two-tier version and one for the, including the configuration for the two-tier variant, and then adding a manifest attribute as well, just to help traceability and to see what version is that. And do the same for the three-tier version with the configuration property and with the manifest addition as well. OK, so of course it could be done by copy-pasting one task all over, but we want to do better than that. Let's have the Java plugin applied, and then we can iterate through these variants. And for each of them, we can just define a task. And by simply specifying the name and the type, you have your task generated on the fly. We can specify the configuration that we wanted to include, and then set the base name for the generated jar, so they would not collide. And simple as that to define an attribute in the manifest. Now, just having these few lines of code enables you to run these tasks and to generate those jars that you wanted. And of course, the list of the variants can be generated from some dynamic source. But let's take a step back and see what this actually is useful for. So if you have some kind of task type and you want to repeat that task type over a collection of items, so in the case of the example, we wanted to generate multiple jars, so we were able to repeat that easily. One thing that you benefit from if you do this is that you get the up-to-date status for each and every of those generated tasks per item. And it's not going to be just whether the whole collection is up to date or not. In our case, it means that if you add an extra variant, then it will Gradle would need to generate that extra jar if the others are already up to date. And it's also useful when you only have a task that is capable of only handling one item per task. So in our case, for example, the jar task can only generate one jar. If you need to generate multiple jars, you need to create multiple tasks. And this way, you can iterate through them easily. So this is something that we benefited from a lot, and it's probably worth remember. Another thing we do is POM customization. So obviously, when you produce Java software and you produce your jars, you usually upload them to some repository. And what we do is upload to a Maven repository and having Gradle generate the POM files. However, we need to customize that. The way that goes is that when you have your upload task and you invoke the Maven deployer in it, you basically get starting to get the POM generated automatically. But by accessing the POM DSL, you can actually do a little bit customization on that. So, for example, you can override or specify the group artifact ID and the version. You can define some version control information about your project. You can add extra properties and manage the dependencies as well if you need to. So why would you want to do that? For example, what we use it heavily for is to add extra properties. And the reason for that is by adding extra properties to the POM, it helps us tremendously with auditing and for support, basically by giving us trace information about how that specific artifact was produced. We don't have to do anything else than define a property map and include information about how where the build was produced, by whom, what version of system were used, when was the build happening, and then assign it to the properties attribute of the project in the POM DSL. And that's it. You have a lot of information in your POM which is easily investigatable. What you can also do, as I mentioned earlier, is you can fiddle with the dependencies. For example, you can define extra dependencies or custom dependencies. Again, going in the project, you can use the dependencies block, and inside you can create a new dependency block where you specify the desired coordinates for your dependency. And you might notice here that you can put any version read there, any custom version, which might be handy if you have some custom dependency handling situation, which I will mention a few more times later on. This can be useful if you have some kind of dependency that you might not necessarily want to use as a project dependency, but you always want to include in the POM. Another thing that we heavily rely on is the POM profiles. Now, this is something that is not necessarily considered best practice. However, it enabled us to facilitate better cooperation with other research institutes way easier. Again, it's a similar idea. In the POM project, you go and in the profiles block, you can define a profile, give an ID, and define on what terms it should be activated, either driven by a property or by simply setting that it should be the active one by default. And then you can go on and customize your dependencies. Just to wrap it up about the POMs, it lets you customize the properties, and it can be really helpful for support and other auditing purposes. You can customize your dependencies, especially the versions as well. And you can use dependency profiles, which is otherwise not really supported by Gradle as far as I know. Moving on, as you heard earlier as well, dependency resolution is a key point in Gradle. And it is a nice way of making it easy to customize it when needed. And we do rely heavily on this. Basically, if you have an old build system where you had some quirks worked out already, and you don't want to change the build of the organization straight away, you can do your own customization of the dependency resolution. A couple of things that we did is, for example, fix or improve the relocation handling. You might know that version-only relocation is not really supported. Well, obviously, relocations are not great at all, but in our cases, we have some old third-party libraries that are still in the system. We use them from external central repositories, and they do have, from time to time, these relocations. For example, the brilliant XML APIs, which relocates from the 2.0.2 version to its 1.0 B2 version. And this is just something that fails straight away with Gradle. Of course, the long-term goal is to clean up these dependencies, but in the meantime, we can provide a little bit of robustness to our build system. Another thing that we did is dependency deprecation. So now we have a plugin where we can define certain libraries to be obsoleted and replaced by other new libraries. And this helps us phasing out these deprecated libraries by automatically replacing them during the build. And the last thing I would like to mention is the version aliases. So I mentioned that pro before. Now this is something that we use similarly as you might use Maven labels, although Maven labels are not supported really. And in our cases, we have two aliases, the latest and the pro. This, as I said before, it comes from our historical requirements, how the old build system worked, and it works nicely, and we were able to manage to implement this logic nicely with Gradle as well. So how would you go about that if you want to augment the dependency resolution? probably you want to iterate through all your configurations because you want it to be consistent across the configurations. You wanted to make sure that the configuration is not resolved yet. It's a silly mistake, but I'd like to point out because you get a nice exception if you don't take care about this check. And once you do, then you can access the resolution strategy for, for each configuration. And for the resolution strategy, you can define a rule for each dependency. You have some predefined rules as well, but you can use this solution to have any custom rule that you might think of. Basically, in the rule, you get the requested dependency, which is the dependency that was initially defined in your build, so mostly in your build.gradle file. And this always stays the original. So you can always know what the original dependency was requested. And you get the target part as well, which at the start is the same as the original, but then can be changed already by previous rules. And basically, based on these two information, you can define what should be used instead of the current target. You can override the target with anything you find correct. And you can put your custom logic there. So let's take an example, because again, I talked about this Pro version previously. You can check if the currently selected target version is Pro, and if so, then you can, assuming you have some lookup solution for resolving the Pro version, you can tell Gradle to use that version. And this is something that we do, and it works out very nicely. Right. So a little bit more about how dependencies in configurations work, and one thing that I'd like to mention about this, because we find it very useful. Let's take an example where you have conflicting transitive dependencies. Let's say we have an application with some libraries that depends on, and two of those libraries depend on two logger implementations, SLL4J Simple and Lockback Classic. I know that this should not happen. However, we know that this does happen from time to time. So of course, this is not a conflict that can be detected by Gradle. It's not a version conflict of the same dependency, but a logical conflict that can be defined on an organization level how it should be resolved. Let's say, for example, that if the policy is that if both dependencies are present, then Lockback Classic should be preferred always. So the goal is to remove SLF4J Simple, but only in the case if Lockback Classic is present. Now, of course, you cannot just simply go and define an exclusion rule. But before we go into that, let me show you how the configuration looks like using the dependencies task, which if you're not familiar with, I highly recommend using it. You can filter for a specific configuration, in our case, the compile, and see that you have the dependencies on these libraries, and they depend on the problematic logger implementations, and they have, of course, some transitive dependencies. This task shows you very nicely how your dependencies look like. And of course, still the goal is to get rid of SLF4J Simple, given that Lockback Classic is present. Now, what you can do is, you can take your dependency configuration, the compile configuration, and copy it recursively. What it does is basically create a clone configuration of your compile configuration. And what you can do with that, and what we do with this, is we access the resolved configuration on it, and then from those we collect the resolved artifacts. Module IDs basically collect what dependencies are involved in the dependency configuration. And this is including transitives, because although there is no explicit mention of it, accessing the resolved configuration on a configuration actually triggers the dependency resolution. So unless you excluded transitives, this way you can access the whole dependency tree of a configuration without modifying the original one. And then we can easily look for the two questionable artifacts, and then make a decision that if both are present, then there should be some kind of exclusion on the compile configuration to exclude the SLF4J from the dependency tree. Obviously, that's a typo. It should be SLF4J, but that's OK. So after applying these few lines of code, we can actually get rid of the SLF4J dependency in a safe way. What I mean by that is that only if our predefined condition is met when lookback classic is present. So to take a step back and summarize it, basically, if you have a configuration, a dependency configuration, you can clone it. And the reason why you might want to do that is that resolving the clone has no effect on the original. You can do whatever you want on this clone without affecting the original one. And an important thing that you can do is investigate how your dependency tree would look like if you would go with the original dependency configuration, including the transitive dependencies. And this allows you to customize your rules and customize your configuration that you actually use during your project build. And this actually lets you overcome the problem that normally you can only resolve one configuration once, but using a clone, you can actually imitate a second resolution. OK, let me talk about a bit about build.gradle. It's something that poses us as a problem because it's flexible and powerful and dynamic, and you can do whatever you want in it. But in our case, it meant that whatever we put in the build.gradle would be duplicated across 95% of the projects. So that's, again, more than 900 projects. And even if it's as simple as defining your repository, your one dependency, and applying a plugin, which would handle everything, that's a lot of duplication. And if you have a lot of duplication, then a certain level of divergence will emerge by time. And we wanted to make sure that we avoid that. It also would have meant that we would need to train all our developers to understand how Gradle works. Now, this is something that we didn't really want to spend a lot of time on. It also limits the way the build can be tooled, because although, as we heard, the support for build.gradle editing, especially with Kotlin, is improving, it's still something that is a bit constrained. And although we do love Gradle, we also have to think about, as our previous build system was used for more than 15 years, we also want to plan for the long run. And if we by any chance have to move away from Gradle, may that they never come, then we have to deal with 900 or 1,000 build.gradle files to be refactored to another solution yet again. So we have an alternative solution for that. And of course, what that is a custom build descriptor. Now, that is something very simple. We have a little XML only describing the very basics of a project, the name, version, the group, and the dependencies of it. Now, of course, this is a declarative way of configuring your build. It has little flexibility. But in turn, what it gives you and what we benefited from is the ease of maintenance that it provides. When we have to do any operation of the thousands of projects that we have to provide support for, then it's easy to iterate through XMLs and analyze them because XML is very easy to analyze. It's also the legacy that we had. So this was something that we had already in our previous build system. Our users were familiar with. And this is something that we wanted to keep to make sure that the transition is smooth. As I pointed out, that was our key restriction. Now, OK, but what Gradle can do about this? So Gradle has a feature, you might not use it very often, is the ability to have init scripts. Init scripts are Gradle scripts that live in your init directory of your Gradle distribution. And what happens to them is whenever you run that Gradle distribution, these init scripts are evaluated similarly as your build.gradle, actually before your build.gradle. And that allowed us to use a custom build descriptor, because in our init script, we were able to do the parsing of these build descriptors and do any necessary configuration. We managed to separate the build logics to be handled in these init scripts and have the project configuration next to the project in these very simple XML files that I showed you before. Of course, it doesn't disable the ability to use build.gradle, so those 5% of projects that needed customization was possible to configure with build.gradle additionally. But I have to point out that this was the single most most important enabler of us providing a seamless migration. What it means is that we were able to tell the user just use a different command, and without changing anything on their project, we can do everything in the init script and provide a seamless transition from the old system to the new one. But let me show you how that simply looks like. Let's say you have a corporate.gradle in your init directory, because corporates like to do corporate stuff. So you can have an init script block, which is very similar to the build script block that you would have in your other Gradle files. You define your repositories there, you define your dependencies there, and then you can iterate through your project and apply Java plugins. This is something we do because we only provide tooling for Java projects, so it makes sense that all our projects need Java. Also, we have some logging solutions, so we apply a logging configuration that we set up in another Gradle file. So again, what I'd like you to remember is that if you have init scripts, it allows you to reduce the boilerplate code that you have in your build.gradle files. In our case, it meant that we only have build.gradle files at all in 5% of our projects. The default plugins are applied in the init scripts. The default configurations are applied in the init scripts. And it's hidden in the distribution. It doesn't bother the users. This kind of lets hide away the complexity of the build. Of course, this means that you have to bundle the init scripts with your Gradle distribution. In our case, it wasn't a problem because we shipped the Gradle distribution to our users anyway. Alternatively, you can specify it on the command line as well to have init scripts, but we mostly use this for debugging only. The key point I would like to point out again is that having init scripts give you a very nice possibility to make a very smooth and very seamless transition to a Gradle build system. Right, so in terms of generally about the flexibility of Gradle, it provides you the dynamic test generation, the possibility to customize your POMs, customize dependency resolution, which can be very powerful and customized to your organization requirements. And the init script is something that helps with the smooth transition. But basically, we managed to find some kind of workaround for all the problems that we faced during the migration. It's not necessarily something that is a long-term solution, the most elegant solution, but there was always some kind of way to work around it to make sure that we can actually move to Gradle. But of course, there were a couple of bumps that we hit along the road, and you might want to avoid these or know that there are other solutions. So we found a bit problem how Gradle and Groovy works. Basically, the problem we hit is that Groovy codebase and Gradle codebase, the DSL, can grow out of control once you start actually going into your real complexity of your build system. It becomes difficult to maintain. The Groovy code is very flexible, but with lacking the static typing and all that, it's a bit more problematic when the code base grows. So what we did is we went back to Java. But of course, this was a decision not only made later because we only realized it later that it's a problem, but also because the Java API of Gradle improved a lot. A lot of things that were only possible to do with the DSL was published or made accessible through the Java API. We started with Gradle 1.something at the beginning, and of course, Gradle improved a lot, and it improved a lot regarding its API as well. And of course, now there's Kotlin, so we are very much looking forward to try it and see while it's maturing and how we can use that to kind of get the benefit of what Groovy would have provided, but still get a maintainable code base. There's a small thing I would like to mention is the version plus. So this is something that is supported by Gradle, and you can use it to use it instead of the version ranges, kind of. So for example, if you define the dependency like this with 1.plus, as its version, then it will give you back the latest 1.something version. The problem we found with this is that it gets to the POM as it is, as a plus, and it breaks the compatibility with Maven. I mentioned before that we have to care about sharing our libraries with other institutes, and they use Maven. And so be careful, if you have Maven clients as well, then be sure that you don't use plus on your versions. Now, I would like to talk about logging because as much as we do appreciate especially the recent improvements in the logging of Gradle, it's very nice, we have some problems when it comes to customization. Basically, we had some ideas what we should get from the logging, and they were difficult to achieve. Many of the things that we wanted to do was only possible through accessing internal APIs to hook into the logging process or to configure some aspects of it. One of the key points was that we wanted to achieve is to log into a file as well as on the console. Now, this is not something that you can do, as far as I know, using the normal API of Gradle, and especially not having a log file with a different log level than your console output. Okay, so we found an alternative. We wrote a custom plugin, a logging plugin, which unfortunately has to use the internal API, but it does provide the facility of logging into files as well, and with a different logging level than to the console. So it simplifies a lot the user experience, or improves the user experience, because the users only see the quiet or lifecycle log level, so they get very concise, nice output. On the other hand, the log file is written, so in case of support request, they can just send along the info log file straight away, and they don't have to rerun the builds, which avoids the problem if there's a transient problem to trying to reproduce it. We also came up with an idea of how the summary should look like. And again, keep in mind that we try to focus a lot on software developers who are not primary software developers, but still they want to use our tools. We need to provide an even clearer error feedback than Gradle normally does. And what I mean by that is that we wanted to summarize all the error messages and warnings at the end of the build in one block to make sure that if the build fails, or even if it succeeds, but there were any warnings or errors, they do end up at the end, so it's easy to point out. So for example, you might have a successful build, but if the test execution was disabled, then it's something that we'd like to point out to your users. Luckily, it's not in many cases, but it does happen. Another thing is the what's next hint. Now, this is something we find very useful. If the build fails, not only to show the error messages or warnings, but also to tell the users what they should try as a next step in their process. So for example, if the test fails, we show them a message to try to disable the parallel test execution, because as you know, Gradle executes the test in parallel by default, but in some cases the tests are not that much of a unit test as the developers might think. So it's a good shot to try that and turn it out. But also, a next step can be useful not only in failure, but in case of a success. As an example, I would like to show you when we run a release, we showed the users where their artifacts ended up. And that lets them quickly go there and check the artifacts out, try them out, and do whatever they need to do with it. And again, going back to my favorite thing, the pro alias, we also show them when this alias was updated during the release. So as a conclusion about the logging, we managed to filter out irrelevant noise and collect the relevant information towards the end of the build. And if you're interested, there's a plan to open source it in the near future, so stay tuned if you care about that. One pain point about Gradle we had is that we managed to migrate a lot of our projects, but there are still very few, and in fact, a few projects in the development tools team which are still using Maven because of the lack of support that Gradle gives to building Eclipse plugins. We found the WAF project, which was very promising 2 years ago, but it actually died 2 years ago straight away. And there's the BND platform, but it's mainly aimed at OSGI. So it lets you package up things as a OSGI bundle, but it still relies on Eclipse or a lot of configuration to be able to build your projects. But we saw that Buildship is built with Gradle, and so we're looking at the Gradle guys very much in hope that maybe that Build.src gets published anytime soon. So us and actually many other projects that adopted Gradle almost entirely, except for the Eclipse project builds, we could use Gradle for that as well. And talking about Buildship, so obviously Buildship provides a very nice integration, a very flexible integration for Gradle in, for example, Eclipse that we use. And it has a nice task view where you can see all the tasks that your build provides. However, again, keeping in mind that we have a very diverse user base, we found that it lacks the simplicity that we look for in an integration as such. It has dozens of unused tasks, and although you can organize these tasks, and they are organized in tasks in groups, you cannot, for example, hide them. And only by applying the Java, Maven, and Eclipse plugin, which is kind of a base minimal for all of our projects, you get this bunch of tasks out of which most of our developers use 2 or 3 at most. And actually, our own tasks, for example, release and so on, are not even included here. It also makes it a bit problematic or difficult to access the arguments that you might want to pass to your tasks. If you want to access that, you have to go on the task, first create, and then open a build configuration, and only then you can see that information kind of hidden away where your build parameters are. Apart from this, we also hit some scalability issues. Now, bear in mind that our developers, especially the library and framework maintainers, have dozens, sometimes hundreds of projects in their workspace. And having to reconfigure these projects each time when they clean their workspace means a lot of waiting. Only this time, instead of the usual waiting for a compilation, they now have to wait for configuration, which makes it even a bit more annoying. So we kind of have an alternative for this as well, which is based on the Gradle tooling, which is nice to keep in mind if you want any kind of integration with Gradle. It's a very similar but a way more simplistic view. So as you can see, you have the tasks. It's inspired by the Endre plugin originally, as you might recognize. And I would like to say thanks to Donat, who kicked off this project when he was still with CERN before joining Gradle. So we're looking forward for improvements on Buildship as well. But it gives the simplicity that we were looking for. We have these tasks defined statically, so these are not generated by any configuration done on the projects, but we have a predefined set of tasks that are listed for each of the projects that are added to this view. You have the common task and also the arguments that are commonly used. So for example, for turning off the tagging in SVN, if that's needed for some tryouts. But it stays customizable. You can parameterize the tasks, adding a little parameter there. You can have combined tasks, so commonly run together tasks can be executed conveniently. And you can also have custom arguments. Now we have task arguments defined on the task level, on the project level, and even maybe globally as well. For example, you might want to easily turn off and on the proxy configuration that you have for Gradle. And this is not something that you can do easily if you're using Buildship. OK. So to sum it up, our primary goal was to move to Gradle because we wanted to step away from an old, outdated build system and make it as smooth as possible. And there were a lot of features of Gradle that helped, but the main ones that I would like to point out is the dynamic text generation, again, the POM customization, the special dependency handling that is very customizable and very easy to fit to your needs, and the init scripts that is really key to make the migration seamless. So if you would ask the question if Gradle can replace any build tool, and they kind of claim that it can, well, our experiences, and we have a very custom, very old and very weird build system that we have to migrate from, we have to say, yes, I think we believe it can. So that's it. Thank you. Any questions, maybe? No? Yeah?
How long did it take to migrate to Gradle?
So I showed you on one of the early slides. We started in 2013. Now the video kicks in. 2013, and it took us around 4 years to make the whole, or 3 years to make the whole transition, actually. Maybe it would have been easier to quickly go there. Yeah, so we started with the Gradle trying out Gradle in 2013, and then by the end, towards the end of 2015, we were able to start with the migrating projects already. But it took 1.5 more years to actually get to a place where we were confident enough to migrate, start the mass migration of our projects. Yes?
How big's the team? How big's the team which takes care of this migration?
Yeah, so it's not a big team, and somewhat to the way CERN is organized, it's a weird situation because we had a lot of turnover in the team. But I would say that the average size of the team was between 2 and 3 members. Yes?
You mentioned that Maven just didn't work. Is there anything like specific you call out as something that Maven just kind of is a deal breaker?
Well, probably the easiest way I would be able to summarize it, that Maven needed to be adopted while Gradle was possible to adapt to our needs. And again, our main restriction was that we needed to make a transition without being disruptive to our users and to the development. And when we tried Maven, we experienced that it needs a lot of changes in terms of structuring of even the code base, the projects, and how the development flow looks like. So that was kind of what stopped us. Anyone else? Yes?
Is there any plan to have projects migrate to a more traditional setup, possibly using the wrapper and dependencies, declarative, build files, use plugins instead of init scripts, and so on?
So this is somewhat of an ongoing debate, what should happen, because as I said before, having the init scripts, it's a bit complicated in terms of how we deploy that, and of course the versioning of the build tool now is not tied to the versioning of the projects, but it does give us the benefit of really not having to duplicate anything across the projects. Not even the wrapper that you might want to change where the distribution should be downloaded from. Nothing is duplicated across the project. So that reduces the maintenance actually for us a lot. But again, it's still something that we have to see in the future once Gradle is more adopted by the users as well, not just the build system side. Sorry, just one more addition. So we actually have now kind of a monolithic structure of this init script addition on top of Gradle, and that's we're turning into plugins. So it's going to be easier to turn off and on different things. And even people who are not using our full infrastructure and not benefiting from the Init script capability, so not having to have a build.gradle file at all if you don't want to, then those could still use our different parts of our build system. Yeah. Okay.
Can you say that the next talk is at 45, 11:45?
Yeah, so 45 is the next talk start. So I guess, again, thanks for all, and Lauren's going to start in 10 minutes. Thank you.